All right. This is going to be the week 12 discussion of text processing and wrapper classes is the name of the presentation. I listed it in the syllabus of string processing. In this lecture, we're going to take an more in-depth look in the wrapper classes because they provide a lot of interesting functionality for us. We're going to talk about character testing and character conversion with the character class. We're going to talk about some different string methods and what we can do with them as far as manipulating our string objects. We're going to look at the string builder class. We're going to look at the string tokenizer class. We're going to look at some wrapper classes for numeric data types. Again, we're going to take a little bit of a deeper look into those as well. When we think about this, we have to remember that Java provides 8 primitive data types, and they're called primitive because they do not come from classes. They are the base types. These are the types that we're going to use to build our class types or our reference types on. Because they are not built from classes, in order to give us functionality to make them useful, like the parse functions that we've been using since 1.11, Java's provided some wrapper classes to give us that functionality. And they're called wrapper classes because they sort of wrap around the primitive data type. These wrapper classes are part of the java.lang library, so there isn't an import statement, as you know. Like I said, we've used these before. Basically, the wrapper classes allow you to create objects to represent primitives. They're immutable, which means once you create the object, you can't change its value. And the value is stored in an object. To get the value stored in the object, you must call a method. And then, of course, they provide the static methods that we have been using most of the semester. The first one we're going to take a look at, though, is, of course, the character class. And the character class allows character data to be wrapped in an object. And the character class provides us with some methods for testing, processing, and converting. We're going to take a look at a chart of the various methods that are provided by the character class that are useful to us. First of all, we can ask the question, is the character a digit, 0 through 9? We can also ask if it's a number, or if it's a letter. So is it an alphabetic letter? Is letter or digit, so is it 0 through 9 or an alphabetic letter? Is it lowercase? Is it uppercase? Is it a space? When we want to change the case of the character, we've got two options. We saw them in the previous slides. To lowercase will allow us to get the lowercase version of a string that is, or of a character that is provided, and to uppercase will let us get the uppercase equivalent of the character that is provided. We're going to jump into strings now that we've talked a little bit about characters. I apologize if this lecture seems like it's a little bit all over the place. This is sort of a hodgepodge of topics that are important for you as a developer to know that these resources exist, but don't exactly fit into any of the other discussions that we've had throughout the semester. So we're going to be bouncing back and forth between the different wrapper classes, some of the functions they have, some of the different string functions that are available, and I am going to apologize for that sort of upfront. But you're going to see us doing some bouncing back and forth, and that's okay. Right now, we're going to bounce into the strings. We've used the string class a lot throughout the last 2 semesters, and there are some things about some methods available in the string class that I think you need to know about. And those methods are, of course, substring. A substring is a string that is part of another string. So substrings, basically, we have some methods, the string class has some methods to allow us to check sections of it or to get sections of data back, sections of the string back, or a substring back. First of all, we have starts with. Starts with looks at the beginning of the string and tries to match up the method that we provided or the string that we provided with the actual string variable we're checking on. We've got ends with, does the same thing towards the end. We've got regional matches. We've got a start. We give it a start. We give it a string, and we can even tell it to ignore the case. In a little more detail, starts with determines the string begins with the specified character. So if the string that we're looking against is 4 years ago, and we ask the question, string dot starts with 4, we're going to get back true. So system.out.println, the string starts with 4 will be executed. All right. Here again, this is the string that we're testing against, 7 years ago, and this is the word that we're looking for at the beginning of the string. And starts with gives us that capability. Starts with is case sensitive. That means since we're looking for uppercase FOURE, we're going to be looking for uppercase here. Ends with works the same way, it just wants to know if it happens at the end. So 7 years ago is our string. Ends with is going to look back at the end and say, okay, OOGGAA, yep, we've got a match. Ends with also performs a case-sensitive comparison, so it wants to make sure that it's a lowercase o and a lowercase o, a lowercase g and a lowercase g, a lowercase a and a lowercase a. And if we put a space here, then it will check for a space here. On and on and on. We can ask if the specified regions of 2 strings match by providing a start, a string, a start on the second string, by providing a start on the first string, the string that we want, a start on the second string, and a count of characters. And this is a case-sensitive comparison, but we also have the option to provide a true or false value to say, hey, we don't want to check the case. We just want to know if the same collection of characters are together. We can ask for the location of a substring. We can ask for the location of a substring within a string. We've got index of. So with index of, we can supply a smaller string that is inside a larger string, and it'll tell us the index of the first part, the index of the first occurrence of the first character of that substring in the larger string. So it'll tell us where it starts. Last index of will tell us where the last location of the substring or character is. So index of gets us the first location, last index gets us the last location, and that's useful because if you've got a huge chunk of text you're checking, it's useful to know if, first of all, where's the first time you saw it and where's the last time you saw it. And we've got some examples of some of the different characters and substring locations that we can find. We've got all of these here. We've got some example code here that you can take a look at and just see for yourself how this all executes. We'll have a couple of examples too as part of the exercises for this unit. If we want to look at all of the string methods that we've got available to us, and there are 2 slides worth, as well as some additional on page 616 of the Gaddis textbook on table 10.4. I'm not sure if there is a similar table in the Java Illuminated textbook for those of you using that textbook, but it is possible. But this table is fairly comprehensive for the I don't want to say the important ones, but for the commonly used ones, I think is a better term. First of all, we've got index of. We can provide a character, and it searches the string for the location of a particular character. And if the character is found, the first occurrence is returned. Otherwise, a -1 is returned. And we can also specify the place to start looking in the string for the occurrence of a character. We've also can do index of a string. So not only are we looking for a particular character, we can look for a particular collection of characters. And we can also, as you see at the bottom, specify the location to start looking for that specific collection of characters. Of course, we have last index of, and we have last index of for both strings and characters, and they work in a similar fashion. In one case, we're looking for a particular the last location of a particular character within a larger string. We can also provide a starting location where to start looking if we want to force it to pick up at a certain point. And we can do this with strings as well. Instead of looking for an individual character, we will look for a collection of characters. And again, on both of these, we're going to get back the index of the starting location where the item is found. And if we can't find it, we're going to get back a -1. When we want to pull out a substring, which is actually kind of useful, we can specify the use of the substring method. And basically, we provide it with a starting location and an optional ending location. We don't have to provide an ending location. And that method will give us that part of the string. So for example, here we've got a full name. Cynthia Susan Smith is our full name, and that's stored in a string variable called full name. And we've created a second string variable for last name, which is really what we want. We want her last name. And we know that 14 characters in at position 14 starts the last name. And how do I know that? Well, if I know the string, I can just count it out. 0, 1, 2, 3, 4, 5, 6, 7, spaces count, 8, 9, 10, 11, 12, 13, 14. The string that I want, the portion of this string that I want, starts at index 14. Now remember, we're looking for the index here, not the position in the list. So it's actually the 15th spot in the list, but the index is 14 because we start at 0. When we're dealing with strings, think of them as character arrays. We start at 0. So this is index 14. So I want, essentially with this right here, I'm saying I want the part of full name that starts at index 14, and that to the end of the string called full name, and stick it in last name. Now here again, full name holds the address of a string object, and last name holds the address of a string object. So they're two separate string objects. If we want to extract our characters in the string to an array for some reason, maybe we need to create an array of characters. I don't know why we would want to do that. Maybe we need to do some sort of sequential search or something. The string class does provide a method to extract a substring, or you can even do it with the entire string, to an array of characters. You can do getChar, which will stores a substring in a character array, or toCharacter array, which takes the entire string object and stores it in the contents of a character into an array of character values. We've even got methods to modify the string. We have a concatenate method that lets us basically mash two strings together. we've got a replace method it's essentially a search and replace for characters. It lets us specify one character, and we can search, and it will search the entire string for that character and replace it with a second character that we specify. There is even a trim function that will take care of all leading and trailing white space that we might have. This is often useful if you're getting your strings from some other source. I realize that this is outside of the scope of this class, but let's say, for example, that you are reading in from a database or reading in from a file. I realize those are outside the scopes of this class, but we could actually sometimes we might have leading or trailing spaces that we don't want, that screws us up when we're processing those strings, comparing them, changing them. We can trim that off with the trim function. When we are dealing with the string class, there is a value of method, and value of the value of method is kind of nice because it will return a string representation of a primitive value or a character array. So let's assume that we have the value true, which is a Boolean value. We can actually turn it into a string true by saying string dot value of. We can do the same thing with numbers if we want. Integer dot parseInt or integer dot no, I'm sorry, this is the other way around. Taking those numeric values and converting them to strings for whatever reason is very simple by simply saying string dot value of, and your integer or your decimal value. In this case, we're seeing right here, 5.0 will come back as a string of 5.0. Same thing with the character C. We can do this with arrays too. We've got some more examples of that over here in this code that you can even do yourself, but you can see what it will produce for you if you wanted to find out. One of the things that you may not know about strings is strings are what's called immutable. They can't be changed. When you create a string object, if you choose to change it or change the value stored in it, what actually happens is it does this all behind the scenes. I don't want to say by magic, but it feels that way. But Java takes care of it all behind the scenes. And what happens is Java basically disassociates your string variable that you created with the current location in memory, assigns it a new location in memory and a new value. And then eventually when garbage collection comes along, when Java's memory management comes along, it will come back, clean up that memory, and make that available again. But in the meantime, you've wasted 2 memory spots. For most things, that's really not a problem. It's something that we do all the time, and we haven't really seen a memory hit in our programs. In a much larger program or on a much smaller system, either one of those could be a problem. So along comes this string builder class. The string builder class is very similar to the string class. We can do almost the same things with it, but we can change. We can change the contents. We can change specific characters. We can insert characters, delete characters, and perform other operations. The string builder object will grow and shrink to accommodate your changes. So let's talk about the string builder. The string builder's got 3 constructors that are of interest to us. The first one, of course, is the default constructor, which gives us enough storage space to hold 16 characters. We also have a constructor that we can call that allows us to specify the length. So we can decide how big, how many characters we need storage space for. Additionally, we can give it a string. We can give the string builder either a literal string or a string variable, and it will create a string builder with at least enough space to hold the string that we've already given it. So these are all very useful items. Let's look at some of the other methods that the string builder offers us. Of course, we have char at. We also have get characters. We have index of. We've got last index. We've got length. We've got substring. All of these methods are available in the string builder, which they also have in common with the string. The string builder has several overloaded versions of the append. Basically, they append a string representation, the string representation of their argument to the calling object's contents. For example, it's whatever the name of the string builder variable is, dot append, and then what we want to add to it. So let's look at an example, because that's kind of confusing as well as frustrating. So let's take a look. Right here we've got a string builder object called str. And we've used the default constructor, so we've gotten space for at least 16 characters, and which is fine because it'll grow and shrink as needed, which is great. But what are the other things we need to know here is that we're going to use the append method to add stuff to it. So first we're going to call the append method, and we're going to add we sold space to our string builder object. Then we're going to call the append method and add 12. And then we're going to call the append method and add another space donuts for $, and then another append 1595. Now we're going to print that out, and what we're going to see is the statement is we sold 12 donuts for $15.95. And you're probably saying, this is great. Why couldn't I have just done string str equals str plus, right? Why couldn't I just have done that? Well, because this would have taken up some space in memory, that would have been destroyed, and then this plus this would have taken up some space in memory, that would have been destroyed, then everything plus this would have been taken up some space in memory, that would have been destroyed, and then everything plus this would have taken up some space in memory, and then that would have been destroyed. So the string builder really makes it easy to add stuff, to tack stuff onto our string as we go, without having to destroy and recreate the string every time, which can get expensive in memory depending on what we're doing. We've also got, with the string builder, an insert method, and that gives us the ability to add items, add characters at a specific location. So we specify where we want the item to start out at and what we want put there. And that can become very useful. We've got a replace method that's just a little bit different. The replace method, we provide a start and an end and what we want to put in that place. So we provide the starting location, the ending location, which is up to but not including the ending position, and then what we want put in there. So the code we've got is we moved from Chicago to Atlanta. The replace function is going to replace Chicago with New York. And that's what this code we see here does. We call replace 14 because that's where we start. 0, 1, 2, 3, 4, 5, 6, 7, 8. Remember, spaces are counted. 9, 10, 11, 12, 13, 14. So we're going to start at 14. 14, 15, 16, 17, 18, 19, 20, 21. So everything between 14 and up to but not including 21. So that's going to be this section right here. That's going to be this right here, this Chicago. We're going to replace that with the word New York. And it's gonna stretch to accommodate. If you notice, New York has more characters than Chicago, and so Chicago is going to be taken out, and New York's going to be put in where Chicago was, and that's what that code's going to do. And so as a result, we moved from New York to Atlanta. And again, it's spread out to make room for New York. Basically, what you're doing here is you're saying take out whatever starts at 14 and goes to but does not include 21 and replace it with this text right here. So it's sort of like a search, destroy, and replace. We can even delete characters at an object. Let's say I ate 100 blueberries is our string builder object. I can delete the 0. So if I want to delete the first 0, I can call delete char at 8, and that'll delete a 0. If I want to delete the word blue, I can call delete 9 through 13, and that'll delete that word. I can display the string builder object, and then I can change the 1 to a 5, and I can say set char at position 6 to a 5, and then I can display it again. And you can copy this code into NetBeans and run it. It's actually pretty cool to sit down and follow through. We've got another sort of string processing function that I think is really useful to know about. It's called the string tokenizer class. And the string tokenizer breaks down a large string into components called tokens. And tokens are words or other items of data separated by spaces or even another character. In this case, if we were to separate it by white space, the string peach, raspberry, strawberry, vanilla would contain 4 tokens. Peach is 1 token, raspberry is the 2nd token, strawberry is the 3rd token, and vanilla is the 4th. We can also separate characters that are delimited, that are separated by a delimiter. Any of you who have done any work with Excel have imported data. You might have imported data from a comma-separated values file. A comma-separated values file is a type of delimited file where each value is separated by a comma. That's the same sort of idea. We could separate this using the string tokenizer. We could separate this based upon the semicolon, which I do a lot when I write data out to a file and I need to delimit that data. I often use something other than a comma because it's just easier. But if I want to read that data back in and break that data up, I can do it by breaking those tokens up around the semicolon. And if that's the case, we would have a token for 17, 92 would be a token, 81 would be a token, 12 would be a token, 46 would be a token, and 5 would be a token. There are problems that you're going to come across in your career that require you to process strings that contain a list of items. For example, think about processing a date. A string is a date. Or think about processing a path, a system path, or a file storage location, whether it's on a network or on a disk drive. All of these things are lists essentially of data separated by values. The date is a list of month, day, and year separated by a delimiter or some sort of delimiting character. Same thing with an operating system path, right? It's a list of folder names separated by a character. In some operating systems, a forward slash. In some operating systems, a backslash. And the process of breaking up this data into its individual pieces is known as tokenizing. And the string tokenizer class allows us to do it. The string tokenizer class is part of the java.util library, and so we'll need to import the java.util library in order to use it. If we look at the constructors the string tokenizer class provides, first of all, when we're using the string tokenizer class, we have to provide it. Whenever we create a string tokenizer object, we have to create it with the items, with the data that we want, with the string that we want broken up into pieces. Now, there are a couple of different options for the way that data could be divided, but the default constructor, we provided the data that we want broke up, and it assumes that we want it broken up on white space. Remember that white space characters are your spaces, your tabs, your new lines. Those are your white space characters. We can also tell it what kind of characters are used to break up the data. So let's say we've got a list separated by semicolons. We can provide it the string and then tell it, oh, the delimiters are the semicolons. And we can even say, hey, the return characters are delimiters as well. This is really one big list. This whole document is one big list of items, and treat those returns not as new line, not as just nothing. Treat those returns as well as delimiters. Or let's say we don't. I don't want you to treat those return characters as delimiters because by default they are. Maybe I don't want to do that. We can set that to false. We can provide the value false in that third constructor, and return won't be considered a delimiter. So if I want to create a string tokenizer object that uses white space, I can make a call to the constructor with just the list that I want, and of course we're going to need to make sure that the items in that list do have spaces to separate them. Otherwise, we're only going to get one token back. If I wanted to create a token where the dash was considered a delimiter, like let's say I wanted to break up a date and I wanted to consider the dash a delimiter, I could do that using the second bullet point, the example we see in the second bullet point. If we look at the example at the bottom of the slide, we can see a one that uses both the hyphen character and the return character as tokens as well while on processing our date. Some of the string tokenizer methods that I think are very important for you are the count tokens. It tells you the how many tokens are left. So it'll give you a count of the number of tokens left. There is also a method called has more tokens, which it's true or false. Yes, there are more. False, no, there are not. Next token grabs the next token in the string and spits it back out to you. And if you try to access it when there are no tokens left, there is an exception that will be thrown called no such element exception if there are no more tokens left. And this slide is great because it gives you a string that's broken up by spaces 1, 2, 3, and we're using a loop here. Basically, we're asking the question. We're saying while has more tokens returns true, keep grabbing the next one. And this is great. I think this is such a wonderful example of how to do that. That of how the string tokenizer works in such a simple fashion. This is what I mostly use it for. This is the easiest way to do it. Uh, sometimes I do a little bit. I do some more complicated stuff, which we're going to talk about in just a second. There are going to be times where we might want to do multiple delimiters. For example, the default delimiter are the whitespace characters, the new line, the return, the tab, the feed, and the backspace, the /b character. Um, Other times, other multiple characters that could be used as a delimiter in the same string might be a situation where you're looking at an email address, right? The @ symbol and the period might be a delimiter. What you might want to do when you are dealing with whitespace character delimiting is use the trim method to trim off the excess whitespace characters from the beginning and the end of the string to make sure they don't become tokens. That's always helpful. Let's say that we want to extract token. Let's say we want to extract both we want to use both the @ and the period as a token to process an email address. It's really easy to do, and this code shows it to you. First of all, we give it the string that we want broken up, and then we provide the characters as a string that we want. So string ticks, we do @ period. That means it's going to use both the @ and the period to break up the email address name into individual tokens, which I think is absolutely wonderful. But this isn't the only way to tokenize a string. The string class also has a split method, which will return an array of string objects broken up by whatever character you choose. I could create my own token, my own sort of tokenized string by following the code we see here. First of all, I have a string that contains 1 space 2 space 3 space 4. And I want to split that up into an array. So I create a string array of tokens, and I call the strings split method, and I give it the character that I want it to split on. I want it to split on the space. So it splits that up into 4 different tokens, and then I can just loop through each item in the array and print out the value is what I'm doing here. I think that is another great way to split strings up, and believe me, I do it all the time. I have an AppleScript code. I realize it's not Java, but I have an AppleScript code that I use to process the Blackboard downloads that I get for your assignments. I use this script I have to process those downloads every week. When I sit down and do your assignment grading, and I use the split because I don't have a string tokenizer in AppleScript, and I use that split to split up the way that Blackboard names the files, so I can find your names and match the assignment up to you. It's a wonderful tool. I love it. I absolutely love it. So the split is another way to do that sort of tokenization of your string without using the string tokenizer class. Personally, I love the string tokenizer class. I will use it always. I still use it whenever I have it available to me in whatever language I'm working in. But split is also an available option. I want to wrap up this lecture by reviewing with you the wrapper classes for our primitive data types, for our numeric data types. Doubles, but the wrapper class name byte applies to the integer byte. The double applies to the decimal double. Float applies to the decimal float. Integer goes with the int variable. Long goes with the integer long, and short goes with the integer short. So they're pretty much the same as their name. The only variation is with the int, and we call it integer. We can actually use these wrapper classes to create objects that hold primitive values, which is absolutely awesome. We can address them just like they were primitive values if we wanted to. If you recall from way back when in the beginning of the semester, we converted strings from, like, say, J-option pane input into numbers. Any string containing the number, like 127.89, can be converted into a numeric data type. And each of the wrapper classes has a static method to convert strings to numbers. The integer class can convert a string to an int. The double class convert a string to a double, and those are all your parse methods. We call them because they are parse byte, parse int, parse short. All of the parse methods will throw a number format exception if the string does not represent a numeric value that will fit as that type of value that you're trying to import, trying to convert it to. So if we try to if we try to take a string and convert it to a byte, and it is either not a numeric, does not represent a numeric value, or is too big for a byte, we'll get something called a number format exception, and that's okay. We'll see that a lot. But the other thing that's kind of nice is the wrapper classes have two string methods that will convert a number to a string. And the method accepts a number as the argument and returns a string representation. So if I wanted to take the integer I, which stores 12, and turn it into a string, I could type in integer dot toString I as the argument, and I would get a string back, which is useful if we ever wanted to do that. It's not hard to do, but we could do it. And if you ever wanted to turn your values into binary or hexadecimal strings or even octal strings, you can do that. Hex strings is hexadecimal. We use a base 10 system. A hexadecimal is a base 16 system. An octal system is a base 8 system. So we can do that with these methods, which I think is great. If you ever wanted to take something and turn it into binary, I thought that was, I would take a number and turn it into binary. I always thought that was kind of awesome. Just for the cool factor of it. There is a 2 binary string method, a 2 hex string method, and a 2 octal string method that we can use. Additionally, if we're ever curious about the minimum and maximum values for a particular wrapper class, each one has a set of static constants called min underscore value and max underscore value. And you can always spit out what the minimum and maximum values are for any given data type. That may come in handy, especially if there are language changes down the road once you leave this class that you need to know about. Well, I apologize for the sort of mishmash that this discussion sort of turned into. I hope that it was an interesting discussion. I know I enjoyed it, covering all of the various little string processing items and character items that we've got in our arsenal should we want to use them. Of course, if you have any questions about this discussion, please feel free to give me a call or email me, bsimbeck@ccac.edu, or bring your questions with you to class and I will gladly answer them for you. Thank you, and I hope you've enjoyed this presentation.